You have hopefully done some of this already. If you haven't, was the tip that I gave you. Let's try drawing both of them. So I'll draw sine in red, and I'm going to continue it back the other way. And I'll draw cosine in blue, and I'm going to try to really make the quarters kind of line up, because those are the important parts, right? The 4 or 5 critical points happen at the quarters. So I'm going to try to make them line up with, whoa. So cosine of x minus pi by 2 is what kind of a transformation?
Phase shift.
Phase shift. Keep going.
To the right.
To the right. Pi by 2, that's a quarter of the graph. So what is an expression, like where does that put you in relation to sine? If I take the blue curve, where does that take me in relation to the red curve? Yeah, very nice. It's equal to sine. So we just say that. How many people already figured that out? That cosine of x minus pi by 2 is equal to sine of x. This is a little bit different than the cofunction identity, because the cofunction identity is pi by 2 minus x minus theta. So those are flipped. But because of even and odd symmetry, there's a lot of parity. There's some overlap here, but it's not exactly the same. It's not set up the same way. Cos of x plus pi by 2. What kind of a transformation is that?
Phase shift to the left.
Phase shift to the left, but the same distance. So where does that put me in relation to sine? Not quite. If I go right, it puts me right on top. If I go left, it doesn't quite. Let me see. I hope this is the one that we want. Actually, this is perfect. Why didn't I think of this before? Loading, loading, loading. Okay, so here we're moving cosine. We're going to move it that direction, right? I moved it too much. There's a quarter. There's sine. Let me go back. If I take cosine and I move it to the left a quarter, it's right on top of sine. And if I show the full graph, you can't fully see it because it's a dotted line, but see it, right? It looks like sine. If I move it the other way, how are they related?
It's flipped.
It's flipped. So this looks like this was like negative sine, right? Let's get rid of this and let's show the full. This looks like sine with a reflection in the x-axis, negative sine of x. Do you agree with that? Do you see that? So this one is equal to negative sine of x. Okay, good. This is good practice, but it's useful for what we're going to do next. Now sine of x minus pi by 2. So now I'm moving to the right, and by a quarter of the graph, I'm taking the red curve and moving it to the right. So what's it going to look like? Hopefully we're getting the hang of this. Negative cos of x. And if I take sine and I move it to the left, what do I get? What do you think? Cos of x, right? Yep. You can draw it, you can visualize it, you can think about it, you could check it with different answers. Don't put, when you're checking an answer like this, like if this is now an identity, right? Not one you're allowed to use, but cos of x plus pi by 2, or sine of x plus pi by 2 is equal to cos of x. Always. That's what an identity means. So if you're going to check that, don't check at points where it might be equal anyway. Don't check at 0 or at pi or 2 pi or pi by 2. Check it at, or pi by 4 would be one. Check it at some other crazy value. Yep.
Why is sine x minus pi by 2 negative?
Okay, let's see. Sine of pi by 2, sine of x minus pi by 2, is that what it is?
Yeah.
We go that way, right? Because it's a shift to the right. So that looks like negative, that looks like cosine but flipped. Do you agree?
Yeah, I must have just drawn a different page.
And then if I go this way, it looks like cosine. It makes sense that if I shift cos to the right and they're the same, I would have to shift sine to the left and they're the same, right? That would make sense. And again, there's not quite the co-function identity. It's not sine of x is pi by 2 minus x. It's x minus pi by 2. Okay, now use a compound angle for cosine. I hope you had a chance to try this. If you didn't, that's too bad you lost your opportunity because we're going to boot our way through it here. What is the, who has the equation, the formula memorized for cos of a minus b? Go ahead.
Cos x, cos pi over 2 plus sine x, sine pi over 2.
So cos, do it this way, a minus b. We're just going to write it down once. Can you do it with a's and b's?
Yeah, cos a, cos b minus, or plus sine a, sine b.
Nice catch too. That's right. You got to change the sign. Okay, very good. So if I apply that formula to this, I get cos x cos pi by 2 plus sine x sine pi by 2. Is that right? But we can evaluate. If you stopped there, whoa, hold on. We can evaluate cos of pi by 2. We can evaluate sine of pi by 2. Right? What's cos of pi by 2? Don't just let Jason and John answer. Yep. 0. Love it. What's sine of pi by 2? I can't evaluate sine of x.
1.
1. So this is gone, and I get just sine x times 1, which is sine of x. We just confirmed what we did with transformations using the formula. That's all. Right? Again, see, like if you can think about it multiple ways, get it multiple ways, show it multiple ways, your understanding is so much better. Cos of x plus pi by 2. Do the same thing. I'll give you 23 seconds to do the same thing with this one if you didn't get a chance to do it with the other one. Okay, so you write out the formula, take a look at what we got. We don't have to evaluate anymore. It's the same one. Sine of pi by 2 is still 1, but the difference is it's minus. So this works out to negative sine of x. Well, wow, like it still worked out the same, right? Okay, how can we develop a formula for sine of a plus b? So there's a few different ways that we could do it. Let's start with this relationship. Cos of x minus pi by 2 is equal to sine of x. So if I start with sine of a plus b, that is equal to cosine of what? A plus b minus pi over 2. So if I do this, that's just the identities we were just talking about. That's just what we just did. I can replace x with anything. So we replaced it with a plus b. X is just the angle, and my angle happens to be a compound angle, but it's still just an angle. Like I've written it as a plus b, but that's still just a thing. Now here's a little trick that we're going to do. Instead of thinking about it like this and like this, think about it like this and like this, because it's the same thing. And rewrite that with the cosine formula. Go. Did you get this? Is that right what I did? Nope. This is right. Here we go. Did you get that? So I've changed this to like this plus this. So I use that formula. Confused myself there for a minute. Right? There's my plus sign. There's one. This is one angle. This is the other angle. So if that's a plus b cosine. So that's why this is a minus sign. Okay. Hope that you're okay with that. So cos A, cos B minus sine A, sine B. But the B is actually B minus pi by 2. Now, use the identities that we already did above and replace cosine of B minus pi by 2 with what it's equal to. Do that. So I got cos A sine B, because cos of B minus pi by 2, cos of B minus pi by 2 is equal to sine of x. And then I have to go up here. Sine of x minus pi by 2 is negative cosine of x. So sine of x minus pi by 2 is equal to negative cos of x. So this is sine A, negative cos B. So this is cos A sine B, sine B plus, because I got two negatives multiplied there, sine A cos B. Sometimes you see the second part written like cosine, cosine, but it's the same thing. Got it. Done. Yes?
If you scroll up like a little bit, so for the second, no, it's like the developing the problem.
Okay.
So the second line is like, let's put a negative in the middle, but like how come, like if it's close, shouldn't it be positive?
So you're saying, you're talking about this and this.
Yeah.
But this is my, yep, so this is what we actually did though. We did cos of, I'm going to use different letters, m plus n, where m is a and n is b minus pi by 2. Right? Do you see that? See what I mean? So I split up the angles in a different way. Nothing wrong with that. So you could do the same thing for sine of A minus B. You could do it, you could derive it the same way, and it would be more or less the same steps. Just the substitutions would be slightly different. Or we could take this formula like we did yesterday. Remember when we came up with cos of A minus B? Then we used that to find cos of A plus B. You could do the same thing here. I think I'm going to skip that right now to get to a couple of examples. So there's a little bit of time for questions at the end. but maybe I'll put it up in a video after or something, or you can look at the one from yesterday, it'd be very much the same. You'd end up kind of substituting things and then thinking about even odd symmetry again, okay, so to derive it. But you want to have all these written down. If you didn't write them down yesterday, there they are. How are they the same? How are they different? Cos of A minus B is cos cos plus sine sine. Change the sign. Coses are together, sines are together. So A plus B, coses are together, sines are together. Change the sign. That's like the rule for cosine. For sine, the signs are always the same on both sides of the formula, but it's sine cos cosine, sine cos cosine, right? You got to make sure you get them straight. Homework today is sine, but it has a few coses thrown in to remind you that the formulas are a little bit different. You got to think about it.
For the proofs for this work for these formulas, are we gonna need to throw them?
Yeah, I'm very much likely going to test you on the proof from yesterday. Yeah. So you can just memorize it, but understanding it, like I said, if you know what to do, we used cosine law, we used length of a line, and we just kind of expanded, subbed in some ones, simplified, and it worked out. Like if you kind of have a general idea of the steps, the algebra works itself out. Look through it a few times, you'll get it. Okay, everybody have these written down? Let's try this. So we're going to use the formula, but there's this extra step to these kinds of problems where you also have to figure out, when I give you sine of pi by 12, you have to figure out what the angles are. How many pi by 12s do we have here? Anybody else want to answer? 1 pi by 12. And think about those special ones from yesterday. What combination of those will give me 1? Yeah, 4 minus 3 gives me 1. So 4 pi by 12s minus 3 pi by 12s gives me 1 pi by 12. So if I break this up into sine of 4 pi by 12 minus 3 pi by 12. And how do I reduce those? Kayla? Make sure you have brackets around these. That is important. Careful of brackets. The learning goal, I think there were some brackets missing in some cases, which can cause problems. Okay, very good. And now the formula. Who remembers it already?
Sine pi by 3 cos pi by 4 minus sine pi by 4 cos pi by 3.
I think you got it.
Oh, wait, really?
So sine cos, sine A cos B, sine stays the same, so minus, and then cos A, which is cos of pi by 3, sine of pi by 4. See, when you remember those little rules, if you remember one formula and you kind of remember those little rules, you know them all, I think. Everybody's different though, so if you have a different way, you have a different way. Now we go ahead and evaluate all of these. What's sine of pi by 3? So this is root 3 over 2. Cos of pi by 4? 1 over root 2. Cos of pi by 3 is a half. Sine of pi by 4 is 1 over root 2. Boy, this looks familiar from yesterday. So that's root 3 minus 1 over 2 root 2. Everybody got that okay? Okay, try this one. Yes, yeah. Strange thing with printing once in a while, it doesn't print, it like skips a character. So bizarre.
So there is supposed to be a pi there?
Absolutely.
Okay.
What'd you get, Danae? What did you get as your? Anybody figure out what you can add or subtract together? There's different ways of doing it, right? If you did it a different way and if it works, it works.
I got 8 pi by 12 plus 3 pi.
Nice. Anybody else come up with that? So 8 pi by 12 is a multiple of 4 pi by 12, right? We said this yesterday. Any multiple of 4 or 3 will work. Okay? Plus 3 pi by 12. Eight pi by 12 reduces to divide by the top by 4, divide the bottom by 4, 2 pi over 3 plus 3 pi over, nope, plus pi over 4, sorry. Divide the top by 3, the bottom by 3. And again, using a formula, sine of 2 pi by 3 cos of pi by 4 plus sine, cos of 2 pi by 3 sine of pi by 4. What's the sine of 2 pi by 3? So we're back to thinking about angles of standard position. That's quadrant 2. Right? It's a little bit less than 3 pi by 3. It's not a full pi, so it's in quadrant 2. Sine is positive, so it's like sine of pi by 3. Okay? So that's still positive root 3 over 2. Cos pi by 4, we already did that, 1 over root 2. Now the cosine of 2 pi by 3.
Is it okay if we write sine pi by 3 instead of 2 pi by 3?
No. Why would you do that? Oh, because it's the same? Well, no, you should write sine of 2 pi by 3 first. You could do an extra step showing the related angles. That's what you're trying to do, right? Show the related angles. Sure, you could do that. At this point, though, if you don't need to, you don't have to. In the last unit, you probably would have to write that step with the related angle. But at this point, the value and figure out the positive and negative, you can do that. Cos of 2 pi by 3, negative 1/2. Very nice. And sine of pi over 4 is 1 over root 2. So this is root 3 minus 1 over 2 root 2. And again, remember, so they're the same. Remember we talked about this. And you could plug sine of 11 pi by 12 into your calculator and plug properly with brackets root 3 minus 1 over 2 root 2 into your calculator. You get the exact same decimal answer. And I would recommend doing that at least a few times. Why are those the same answer? Who can tell me that? Wonderful. 11 pi by 12 is quadrant 2. It's almost 12 pi by 12. It's pi by 12. It's 12 minus 1. So that's quadrant 1 angle, quadrant 2 angle. Nice. Any questions?